So I'll just quickly introduce myself. I am Mitesh Khapra. I am an assistant professor at the Department of Computer Science at IIT Madras. And I work mainly in natural language processing and a little bit of computer vision. And for both these areas, the underlying technology that I use very often for my work is deep learning. So I'll give you some introduction to deep learning over the next 3 lectures starting today. So today we'll start with something known as feed-forward neural networks. So that's the goal today. What are feed-forward neural networks and how do you train them? So that's what we'll try to, roughly what we'll try to cover today. And tomorrow we'll look at 2 other types of neural networks, which is convolutional neural networks and recurrent neural networks. So let's start. So here are some acknowledgements. I've borrowed ideas from various places while compiling this lecture, so I've just mentioned those. You can take a look at them. So let's start with a shallow neural network. So before we go on to deep neural networks or deep learning, let's talk about shallow neural networks first. Right? So we'll take this task where we want to predict whether we would like a movie or not. Right? I mean, so there's a new movie which has released, and you want to decide whether you should go watch the movie or not, or in other words, you want to decide whether you would like the movie or not. Right? And suppose, for the sake of simplicity, we base our decisions only on 3 inputs, and these inputs are again binary, right? So the inputs are who is the actor. So I'm taking is the actor Matt Damon, is the genre thriller, and is the director Christopher Nolan, right? So these are the 3 things on which I base my decision, right? So all of these are yes/no answers. So I'll ask these 3 questions, and if I get favorable answers to these, then I'll decide whether I should watch the movie or not. Okay. Now within this, it is quite possible that certain factors are more important than the others, right? So now this is a very toyish example, but if you consider even your day-to-day life, right, you might base your decisions on various factors, but some are obviously more important than the others. So for example, here if there was a factor which says, am I feeling all right today, or do I have a temperature today? If that factor is on, then there's no way I can go and watch the movie, right? So there are some factors which are more important than the others. In this toy example, maybe it's more important for you whether the director is Christopher Nolan or not, right? So that means even if the actor is not Matt Damon, even if the genre is not thriller, as long as the director is Christopher Nolan, you'll probably go and watch the movie, right? So some people have a choice of directors or a choice of actors. No matter which movie that actor or director does, you'll go and watch it, right? So in that case, you might want to give a higher weight to that particular factor and a lower weight to some other factor, right? Just as we do in a lot of decisions that we take in our day-to-day life, right? So what it means is that you have these 3 inputs, x1, x2, x3, which are binary. And with each of these inputs, you would want certain weights to be associated, right? And you would want to weigh the more important factors higher and the less important factors lower, right? So that's what you would like to do. And then there's this additional thing called bias. And it's called bias because it represents your own prejudice, right? For example, if you are a niche moviegoer, right, who only watches movies directed by Christopher Nolan in which Matt Damon has acted and the genre is thriller, right? Only if these 3 conditions are satisfied, then you'll go and watch the movie, right? That means you have very strong criteria for taking this decision. And the way you're going to take this decision is very simple. What you're going to do is, you have these 3 inputs, x1, x2, x3, and 3 weights, w1, w2, w3. Right now, I've not told you how you're going to compute these weights. As humans, we have these weights in our minds, right? We know, okay, this is more important than the other thing. But how does the machine come up with that? I'm not telling you that right now. I'll tell you during the course of the lecture. For now, just assume someone has given you these weights. And the way you're going to decide whether to watch this movie or not is very simple. What you're going to do is, you're going to take a weighted product of your inputs. So you'll do w1 into x1 plus w2 into x2 plus w3 into x3. Where x1, x2, x3 can only take 1 or 0 values. They're either on or off, right? You'll take this weighted sum, and if this sum crosses a certain threshold, then you'll go and watch the movie. Otherwise, you'll not go and watch the movie. Does that make sense? And you can relate it to a lot of decision-making problems that you deal with daily life. So only if all of this is true, only if the risk is worthwhile, then you'll go and do this thing, right? So you'll take a weighted sum of all your factors, and if that weighted sum is greater than your threshold, then you go and watch the movie. Okay. Now let's assume for a minute that all the weights are positive, and all the inputs are anyways positive because they're only 0 or 1, right? Now, if you are an avid movie watcher, what do you think would your threshold be? What would the value of theta be? So your sum of W1x1 plus W2x2 plus W3x3 should be greater than theta. Then you will take the positive decision or you will take the negative decision, right? So if you are a very, very avid movie watcher who goes and watches almost every movie, then what is the value of threshold going to be for you? 0, right? Because you'll make sure that no matter what the actor, director, or genre is, your sum of Wixi is going to cross the threshold. Now, if you are a very niche movie watcher who only watches movies which are directed by Christopher Nolan, has Matt Damon as the actor, and for which the genre is thriller, then what is your threshold going to be? High. Can you give me a number in this case? Assume all the weights are 1. 3, right? So we'll make sure that W1x1 plus W2x2 plus W3x3 is less than this threshold if any of these conditions are not satisfied. How many of you get this? Please raise your hands. Okay, good. So that is this model that we are seeing is something known as a perceptron, which bases its input, which bases its decisions, or rather its output, on the weighted sum of its input. If the weighted sum of the inputs is greater than a certain threshold, then the output would be 1, or else the output would be 0. Okay? Now the question remains, who gives you this threshold and who gives you these weights? Right? Because as I said, for humans, it's very easy. We don't even have these numbers. It's not that every time we have to watch a movie, we do this calculation, come up with a number, check with whether it's greater than a threshold or not. But we have some mechanism in our minds where these weights and numbers are fixed, and we can come up with the answer. Right? But for a machine to do this, it has to learn these weights, and I have not told you how to do that yet. And that's what this lecture is about. I'll get to that. Right? But for now, I'm just motivating that this is a very simplified model of how the human brain works. It takes a lot of inputs from various factors and then produces an output. Right? So one analogy of this could be that suppose you're watching some sitcom, say Big Bang Theory, and then you're getting a lot of inputs from various sensory organs. Right? Your eyes are watching something. Maybe what you're watching, just the expression on the person's or actor's face is funny. Your ears are also getting some inputs. Maybe this, the particular dialogue that you're hearing is funny. Right? And so based on these things, you decide, you take all of these inputs, and then your brain decides whether to laugh or not, right? In a very simplified explanation of why you laugh, right? Of course, it's much more complex how our brain functions, but you could relate, if I had to give you a very bare minimum, bare bones explanation of how it works, then that's how it is. You take a lot of inputs, and based on these inputs, you take a decision. And that's exactly what this simplified perceptron model is trying to do, okay? Fine. And as I was saying, that for a avid movie watcher, the theta would be 0, and for a very niche movie watcher, the theta would be high. And these weights and bias is something that we need to learn. And how does a machine learn? It learns from the past data that you have, right? So you would know so what you will tell, suppose you want a machine to make this decision for you. What you'll have to do is, you'll have to give a lot of past movies which you liked. So you'll have to give it a list, this is the movies which I liked. And from there, it will extract these features. Okay, for this movie, the actor was so-and-so, the director was so-and-so, and the genre was so-and-so. And with all this data, it will try to learn these weights and biases. How is again a question, and we'll get to that. Fine. So now in this very simplified model, in the very simplified perceptron model, the way the perceptron works is using this thresholding logic. You do the weighted sum of the inputs. If the sum crosses the threshold, you take a yes or you take a no. Now notice that this thresholding logic is actually very harsh. Why am I saying it's very harsh? Okay, so let's take an example, right? Suppose I base my decisions only on one input, okay? And that input is, what is the critics rating for this movie? So there's some website online which gives you the critics rating. And that rating, let's assume for the sake of simplicity, lies between 0 to 1, okay? And also let's assume that your threshold is 0.5. That means if your weighted sum of the input crosses 0.5, then you will watch the movie. Okay? And again, let's assume that the weight is 1, because there's only one input, so we're assigning a weight of 1 to that. Now what would happen for a movie which has a rating of 0.51? Will you watch the movie or will you not watch the movie? Watch, right? Because the weighted sum of the input is going to be greater than the threshold, right? What about a movie which has a rating of 0.49? Okay, so now can you reconcile with the first statement which I made? Isn't this a bit harsh? Right? So 0.51 means you like the movie. 0.49 means you'll not like the movie. That's not how we base our decisions, right? Probably you'll watch, as a human, either you'll watch both the movies or you might not watch both the movies, right? It's never going to be that 0.51 is very good and 0.49 is very bad, right? And that's exactly what this perceptron is doing. It's taking the weighted sum of its inputs, and based on that weighted sum, it's saying this is good, this is bad, right? Does that make sense? Okay? So that's why I say it's a bit harsh. And that's exactly the example which I've given here. Now you might say maybe this is a characteristic of the specific problem that I've taken, right? Maybe it's because I've taken only one input, maybe because I set the threshold in a particular way, or maybe because I set the weight in a particular way. Do you think it's because of that, or there's something else at play here? So remember, the way the perceptron works is summation wi xi, right? Where I is equal to 1 to n. What are these n things? The inputs. What was n in our case? 3. We had these 3 inputs. If this is greater than theta, right, then y is equal to 1. Okay. Else y is equal to 0, right? That's how the perceptron operates. Now, can you tell me how this function looks? How does this function look? Suppose I, on the x-axis, plot summation wi xi. Okay? That's what I'm plotting on x-axis. And suppose this point here is theta. Suppose this point here is theta. And this is my y-axis, which is my output. Can you plot this function now? As wi xi keeps growing, till it reaches theta, what would happen? 0. When it reaches theta, 1. What does this look like? A step function. Hence it is harsh, right? Because up to a certain point it's going to be 0, and after that it's going to be 1, right? So it's not, so all of you agree it's not a characteristic of the problem that I took, or the funny way in which I set the weights and the threshold, right? It's basically this function itself is the problem. This function behaves like this, that it is going to give you output 1 only when your input sum crosses a certain threshold, otherwise it's going to be 0. So this is not a dash function. Okay, good is a good answer. No. This is a very good function. Okay, so this is not a smooth function. If it's not a smooth function, what's the problem? It's not. Why do we care about differentiability? Okay, so we'll get to that. Okay, so for now, let's understand this, that this is not a smooth function, right? And whether you understand what is smooth or not, visually you should understand that this is a problem. There's a problem with this function, that it behaves in a very harsh manner, okay? So that's what we want to fix. What about this function? This is a smooth function. And this is a smoother version of the step function, right? The first function is the step function, the blue one. And what I've drawn now is a smoother version of the step function. Do you know what function this is? Sigmoid. Okay. Can you tell me how do you compute the sigmoid function? 1 by? Okay. Is that for any sigmoid function, is that the formula? The question should itself give you the answer, right? So sigmoid is not a function. Sigmoid is a family of functions. The formula which you gave me is for the logistic function which belongs to that family. Any function which has this S-shape is called a sigmoid function. Which other function do you know have this S-shape apart from the one which you gave me? The one which you gave me is logistic function. Apart from that, have you heard of the tan H function? Right? So that also has an S-shape. Right? So all these functions which have these S-shaped belong to the sigmoid family of functions. And the one which we are going to focus on is the one which you told me, and which is the sigmoid function, right? So this is the function that we are going to focus on, the one which you see on the slide. Okay? Does that match with the formula that you are trying to tell me? Is it the same? Right? Okay? Now, when... okay. So what happens if this sum that you see in the bracket, if this sum takes on a very high value, what happens? What is the range of the logistic function? What values can it output? Between 0 and 1. When does it output 0? When would it output 0? When? No, so okay, so let's just back up a bit, right? So whenever I ask you how does the function behave, what do you know the outputs? The outputs are going to be between 0 to 1. So when I'm going to ask you how does the function behave, what do you need to tell me? You need to tell me something about the inputs, right? At what inputs will it give you a high value? At what, and what's the highest value possible? 1. At what inputs will it give you that value? No, the threshold is here, right? Midway. The threshold is there, where the hand is there. Right? So what happens if the exponent, the value inside the exponent, if it's very high, if it tends to infinity, what happens? It will be 1, right? Because it will be e raised to minus infinity, which is going to be 0, so it's 1 over 1. Now, can you take this and tell me when is it going to be 0? When the value inside the bracket is minus infinity. So that means when it's very, very high, it's going to give you a value close to 1. And when the value inside the bracket is very, very small or very, very negative, it's going to give you a value close to 0. Does everyone get that? Okay. So now when is it going to output a value 0.5? When? When what is 0? Value inside the exponent, right? So when this W0 plus summation Wi xi is going to be 0, it's going to become e raised to 0, which is 1. So it's going to be 1 over 1 plus 1, which is 1. How many of you get this? So I want everyone to understand when it's going to give you the extreme values and the middle value, right? So extreme high, when the value inside the bracket is very high. Extreme low, when the value inside the bracket is very low, right? And 0.5, when the value inside the bracket is 0. Okay, so that's how the logistic function behaves. Okay, fine. And in particular, note that we don't have this sharp transition around W0. We have a very smooth transition. Everyone gets that? Okay, fine. So this is the comparison between perceptron and what I've introduced now, which is a sigmoid neuron. Okay, so perceptron had this harsh logic. It used to look, so just notice a few things, right? Both of them look at the sum of Wi xi. Do you get that? But perceptron has a very different way of looking at it. It says I look at the sum and output a value based on whether it's greater than or equal to 0. Okay? And the way sigmoid neuron does it, it looks at this sum and it computes this sigmoid function. It computes this logistic function, which is a much smoother function. And based on that function, you'll get the value between 0 to 1. Both of them are going to output values between 0 to 1, except that perceptron will output only the extreme values, but sigmoid will give you all the smooth values also. Is that fine? Everyone gets this? Okay. So this is how it looks. So perceptron is not smooth, not continuous at W0, and hence not differentiable. And what about sigmoid? Is it differentiable, smooth, continuous? Right? Okay. Fine. So what next? So what I have done so far is I have given you a very toyish example of a decision-making problem. Now the same problem, you can map it to much more complex problems, right? So what I've told you is whether to watch a movie or not. Map it to something more complex. You're a bank. You're trying to give out a credit card. You want to decide whether the person is going to commit a fraud or not. That's again a yes-no answer, right? That can again depend on several factors. Can you give me some factors on which it would depend? So in this case, I told you it depends on who was the actor, who was the director, what was the genre. If I give you a problem of credit card fraud detection, can you tell me some factors on which you would like to base your decision on? Job is? Nationality, okay. Bank balance? Type of? Type of the? Type of the account? Family size? Salary, past, expenses, nominees, so on. So you can think of various things based on which you would make this decision. Now, in your mind, do you have an answer for which is the most important factor on which it would decide? Actually, frankly speaking, no, right? There are many factors that could decide on any of these, right? I mean, it could just be that this person has a good salary, everything. Maybe yesterday he went and betted on some IPL game and now he's in need of some money or something, right? So it's very hard to decide these things. But what you could do is you could take a lot of data of people who have committed fraud in the past, take out all these factors for them, and then try to do what? Learn what from this data? Learn the weights, right? So you don't know which of these factors is important. The only thing you can do is take a look at a lot of this data and see what does the data tell you, right? So what is your quest? What do you want to learn? Doing the feature engineering part, I'm not saying it's easy, but in many cases you can at least come up with a basic set of features, right? Between us, within 1 minute, we could come up with some 10, 15 features. If I give this to you as a job, and if I give you a week, you might be able to come up with hundreds of more features and do that, right? But what you cannot do manually in most cases is learn these weights of the features, right? So now what is your quest? You can design these inputs x1 to xn, but what do you want to learn now? Everyone? The weights, right? So we need, so this model is fine. This model is okay. It can give us a decision between 0 to 1. We feed it values and it will tell us whether the output is between, what's the output between 0 to 1? And what can you interpret that output as? What other quantity do you know which lies between 0 to 1? Probability. So you could interpret that as the probability of that person committing a fraud. And you could base your decision on that. So if there's only a 0.2% chance that he or she will commit a fraud, then you might be okay with giving the loan. But if it's in the higher 80s or 90s, you might not be so okay, right? So you can interpret this number as a probability instead of interpreting it as a 0-1 decision, right? Okay. So now, but what you need still is these weights. How are you going to learn these weights? So that's what we have to do. So we need a way of learning the weights of the sigmoid neuron. And this brings us to a typical machine learning setup. This is very important. You understand this slide properly. It kind of summarizes what you typically do in a supervised machine learning setup. Okay. So what you'll have is data. You'll have the x's. What are the x's here? Features. And you have, I've said that I is equal to 1 to n. So can you tell me what exactly does this x comma y look like? So what I've said is xi comma yi I equal to 1 to n, right? Okay. Now what I'm asking is, what does this data look like? I want the answer to be a matrix. So can you tell me what it looks like? What are the rows of the matrix? So let's try to do that, right? So we'll try to do that. So we have x1, x2 up to xn. And we also have y1, y2 up to yn. So if this were the case of credit card fraud detection, what would these dimensions be? Say the salary, okay, family size, past history of expenses, or something like that, right? So many of these. So we'll have x11, x12, all the way up to x1m. There are m of these features which you have constructed, right? And for that, you have the answer, whether this guy had committed a fraud or not. So this answer is going to be what? What value is it going to take? 0 or 1, right? So for some people, it would be 1. For many people, it would be 0. Okay? So this is what the matrix looks like. It's a, what's the dimension of this matrix? N cross M, right? M is the number of features, and N is the number of data points that you have. So these are all the customers whose past records you have, and you also know whether they have constructed fraud or not. So using this data, what do you want to do now? Learn the weights, right? Okay, good. So let's switch back. Okay. So this is the data given to you, right? So when I say data, you have to think of this matrix which is given to you, okay? Now, what does a model mean? You've heard this term model many times before, hopefully many times in the summer school itself. What do we mean by a model? So then you're saying it's a function, right? A mapping from input. Okay. So what, in the context of machine learning, what does a model mean? So let's try to understand that. Okay. So remember that whatever problem you are given, right? So let's consider a few problems. One is the movie detection problem, and we can actually scale it up, right? I just took a very toyish example where I had only actor, director, and genre, but I could take a lot of other factors, right? What is the box office collection? What is the past history of this production house? Is it known to produce good movies or not? Whether it's an animation movie, and various things that you could consider, okay? So you have that x comma y, so I'll call this as the matrix x, and I'll call this as the vector y. So this x comma y, you could have movie recommendation as one of the jobs. The other one was credit card fraud detection. Okay. Now one more, which is my favorite, I'll call it as the oil mining example, right? So I'm a big oil company, and I want to decide whether this next location that I'm looking at, what's the probability if I start digging there, I'll find oil. Okay. That's again a yes/no decision. And you can relate to it that this is a very real life world important decision to take for these big companies, right? Because it takes a lot of time to invest into setting up a drilling station and all. So they would want to know whether a high quantity of oil can be mined from that location or not, right? Can you give me some factors on which this would depend? Again, think of this as somewhere in the ocean, right? Can you think of some factors on which this would depend? Density. Because there's a process involved in these oil and natural gas which gets formed, right? So it would depend on certain things. So let me give you a few factors, right? I'm not an expert in this field, but let me just say a few, right? So it would probably depend on the density of the water at that location, maybe on the salinity, maybe on the pressure on the surface of the ocean bed at that point, maybe the depth of the ocean at that point, maybe the marine life. Maybe it's possible that in places where you dig up a lot of oil, maybe the marine life diversity is not enough there or something of that sort. Right? You can think of a lot of factors which you can come up with. And what is your why in this case? Yes or no, right? But you could also think of a different why. I might get a bit more ambitious and actually try to predict the quantity of oil, right? Whether I can mine so many gallons of oil or not, right? Because only if it crosses a certain threshold, I might be interested in investing there, right? Now, in all these cases, whether I take oil mining or movie recommendation or credit card, what you have is you have an x, right? And this x is multidimensional, right? So you have, what is the x that we have considered here? X belongs to what? Rn, right? In this particular case. Okay, it's an m-dimensional input. Okay, this is what your x is. What you're interested in is you're trying to predict a y which is a function of x, right? Is that fair enough? You're trying to predict a y which is a function of x. Now, in nature or even in this economic setup of credit card or even in the movie recommendation, it's conceivable that there is a true function which exists between y and x. The only problem is you don't know what that true function is, right? If all of us knew what this function is, which relates the input to how much oil you can mine from that location, all of us would have been billionaires, right? But we don't know what this true function is. And in machine learning, our quest is to find this function. And not find the function actually, find something known as a parameterized form of this function. So I'll tell you what that means. So first understand that we know that this function exists, but we don't know what the function is, right? We don't know whether y is related to x by the sine function or the cosine function, or is it a sine of cosine of e raised to x, or is it a tan of cosine of e raised to x? We don't know that. All we know, there's some function which exists. What we do in machine learning is we assume some form for this function. We say that I believe y is a function of x, and the function is the following. What is the function that we considered so far? Which was the function? The logistic function, right? We said that y is equal to, I'll just call it sigmoid of x. Okay? Then I'm done, right? So I can just, instead of sigmoid, let's take something much easier that I understand, that all of us understand. Right? Let's suppose I had said y is equal to sine of x. So what I'm saying is that whether I like this movie or not, it's actually a sine of the input. It depends as the sine of the input. Now this again takes a value between -1 to 1, and I'm fine with that. If it's close to -1, I'll say I don't like the movie. If it's close to 1, then I like it. What's wrong with this? is there any learning involved here? Do I need to learn anything here? But I just said y is equal to sine of x. I have not introduced any weights. Do I need to learn anything here? No. Now let's take something even simpler, right? All of us are used to this. What is this? Equation of a line. What are the parameters in this equation? M and C. How do you learn M and C? What do I need to give you so that you can learn M and C? I have to give you some data. How many data? 2 data points are enough in this simple case. You get the analogy now, right? So now what I've done is I've introduced certain parameters. And now I'm saying that I'll give you some data where you'll have the x and the y, and using this data, go and learn these parameters. Now this is a very simple case where all of us are used to learning this. But I could make it as complex as possible. Right? I could have said that y is equal to sine of mx plus c. Would things change drastically? Of course, you couldn't write that closed form solution that you are used to. But now you can imagine that something similar is at play here. I can give you data, and you go and find out the parameters such that this fits the data well. Does that make sense? That's exactly how you learn the equation of, the parameters of the equation of a line. Okay? So that's what we do in machine learning. We say that y is related to x by some parametric function. What are the parameters in the case of the logistic function? Everyone? What are the parameters there? The weights, the w's, right? So we have said that I believe that y is a function of x, that y is related to x via the sigmoid function, and these are the parameters of the sigmoid function which I need to learn now. Everyone gets that? Okay?